Hello and welcome to another math-tastic video here in Mathland. Today we're going to go over the factor theorem. Now the factor theorem is used when we have a polynomial that can't be factored by our traditional factor methods, like the AC method, or the guess and check, or difference of squares, difference or sum of cubes, stuff like that. So we've got four terms here. If we group these two terms together and those two terms together, we can't factor anything out of there. So we have to use something else. So here's where the factor theorem comes in. What we're going to do is look at our last term, which is the constant, and our first coefficient. So this guy and this guy. Okay, so in Mathland, we call this one P. We call this one Q. Just so it's different, and we like letters, so there you go. And we're looking for P over Q. So factors of P over Q. Now let's go ahead and outline our factors of our last term and factors of our first term. So 6. Factors of 6. So we could have 1 times 6. We could have plus or minus. So we'd have -1 times -6. That makes 6. Now here the sign doesn't really matter because we're just looking for factors of that number. We can have plus or minus any of these numbers in between for factors. Okay, so 1 and 6 and 2 and 3. They all make 6. Those are factors of 6, which you should know already. And now we're going to write down our factors of 2. The only factors of 2 are 1 and 2, plus or minus. Okay, so like I said before, we're going to put factors of P over factors of Q. So we're going to group these all together. I'm going to put my plus or minus. Here I'm going to put possible factors. Now when I say possible factors, I mean that when we solve this, we want to get down to some kind of smaller polynomial. So we want to get down to a binomial or a trinomial. So over here, I'm going to put a little note, possible factors. So if I have a possible factor of -1, let's say that works. If I were to write that in a binomial form, it would be x plus 1. Because when we have this as a factor and we solve to set it equal to 0, we're solving for what x is. So x would equal -1. So if we find a possible factor, that's what we see right here. X could equal that number. But to write it in a factored form, we need to put it in a binomial. So we're going to change the sign to put it in a binomial form. Okay? So this is an example. If it was -1, if -1 worked of these possible factors, we need to write it like this. Okay, so I'm going to list all my possible factors, but how many are we looking for, right? I don't know. Wait, no, I do know. Because it's our leading term, our leading coefficient, or not coefficient, but our leading term here. We look at that exponent. It says 3. That is a 3, by the way. So we're looking for 3. So once we get to 3 factors that work, and I'll show you how it works, we can stop. Okay, but now let's get back to listing our possible factors. We have 1 over 1. Remember, it's P over Q. So 1 over 1 is 1. 2 over 1, that's 2. 3 over 1, that's 3. 6 over 1, that's 6. So the plus or minus goes with any and all of these terms. I'm still not done because I have to write our factors of P over Q. So I just did factors over 1 of the Q terms. So now I'm going to do, I did 1 over 1, and let's do 1 over 2. So I also have 1/2, plus or minus 1/2. And I have 2 over 2, which is 1. I've got that. And I have 3 over 2. And then 6 over 2 would be 3. Okay, so these are all my P's over Q's. Okay, so we want to pair this number with the first one here, first factor of our first coefficient, and all of our numbers over the second factor of our first coefficient. Okay, possible numbers. Remember, we're looking for 3 of them. Looking for 3. Okay, so the factor theorem gives us a bit of a shortcut on how to check these things out. So these are the possible x values. Remember I said x equals that number, and then we'll put it back, if it works, we'll put it back into a binomial form. So if x equals one of these terms, I can substitute these values into the x value in our original equation. So let's try positive 1. So that would look like this. 2 times 1 to the third power plus 1 to the second power minus 13 times 1 plus 6. And we want it to equal 0. If it equals 0, then it works. I'm going to list the negative 1 too. Okay, 2 times negative 1. 3 plus negative 1 squared minus 13 times negative 1 plus 6. Okay, so let's get our handy dandy calculator out here, if we can see the screen. Okay, so I'm going to punch that in to open parentheses. Can you see what I'm doing? Yeah, there we go. Okay, right there. 2 times 1, close parentheses, square that, plus 1. I know you could probably do this in your head, but I'm just showing you how. Oops, that was supposed to be 3. 3. Okay, plus 1 squared minus 13 times 1 plus 6. Okay, so I got it on there. What does it equal? Negative 4. So that equaled negative 4. That does not work. So 1 does not work. Let's try negative 1. So the shortcut to use the calculator, is to hit second entry right there. So second entry. It's going to pull up your previous entry, and I'm going to insert a negative 1. So I've got to insert, second insert, negative 1. Second insert, negative 1. And over here, second insert, negative 1. Okay, so I've got all my negative 1 values in there. I've got 18. That doesn't work. Okay, so I'm going to keep going down the line to figure out which ones equal 0. So let's try 2. 2. So ones, neither of them worked. 2, I could try 2 and negative 2. So 2 times 2 cubed plus 2 squared minus 13 times 2 plus 6. Oops. Equals. Okay, I've got everything in there. I'm going to hit second entry, and the one before didn't have a negative, so I'm going to hit second entry again. I'm going to plug in a 2 everywhere I had a 1. 2, 2, 2. It equals 0. Yay! See that? 0. All right, so one of them works. 0. Yay! So we need 3. Remember, we have 1. We need 2 more. So from this point, we can use synthetic division or long division to find our quotient and then factor from that point. Or we can keep punching these numbers in to figure out if any other numbers work. So let me write this down. Negative 2 plus 6. Okay, I'm going to see if negative 2 works. Got second entry, I've got the negatives. I'm going to go negative 2, negative 2, negative 2. Okay, that does not work. 20. Yuck. Okay, let's go with 3. So 2 worked. 3, let's see if that works. 2 times 3 cubed plus 3 squared minus 13 times 3 plus 6. Okay, so enter second entry. I'm going to plug it in where I had the positive 2, and I'm going to change that to a 3. So I'm changing that one to a 3, that one to a 3, and that one to a 3. Okay, I plugged them all in. Okay, that's 30. That's not going to work. Okay, that's a no. Negative 3. 2 times negative 3 cubed plus negative 3 squared minus 13 times negative 3 plus 6. Okay, so I'm going to get back to where I had negatives. So I'm going to plug in a negative 3, negative 3, negative 3. Ah, 0! Hooray! Okay, we've got 2 of them. Let's try to find the others. So I've got that, negative 3. I can do 6, but I'm going to skip ahead to the fractions here because whole numbers are pretty easy to work with. Let's try our fractions here. So let's go with 1/2. 1/2. So you can plug it in the same way with the calculator, or again, you can use long division or synthetic division. There are videos on those if you need help with that. Okay. Just make a note that if you're going to use long division, after you find one zero that works or one factor that works, you need to put it in with the opposite sign. So if 2 worked, which it did, you're going to put x minus 2 and then do the long division that way. Okay, so just a note, you have to put it back in that binomial written form. Okay, so 1/2. We're going to do 1/2 here. Put it in the calculator. So second entry, I'm going to change this negative 3 to 1/2. Oops, I need to find room first. I'm going to say second insert, 2. So 1/, second insert, 2. And then 1/, second insert, 2. Ah, it's 0! 0! Okay, look, I have 3. 3 components. So the numbers that worked, as far as our possible factors, were 2, negative 3, and 1/2. Okay, but we now have to put them back in binomial form. So we need to change the signs to put it back in binomial form, because when we solve for this, we get an opposite sign, and that's what we found over here. These are the possible numbers that x could be. But now we need to write it in one step before that in binomial form. So this is going to look like x minus 2 and x plus 3 and x minus 1/2. Okay, just a note, we don't want to put fractions in our binomials. So we need to change this. We need to take the denominator, if we do end up with a fraction, and stick it in front of that x value. So truly our answer is x minus 2, x plus 3, and 2x minus 1. And you'll see how that happens when if you look at the bottoms up video or a new method for dividing polynomials. Okay, there we go. It seems a bit lengthy, but you'll have the help of a calculator, so you should be good to go. Hope you enjoy it.